Lesson 2.9, we're talking about coordinates and polygons. What we're going to be doing in this lesson is we're going to be able to, by the end, we're going to be able to graph a polygon using coordinates, using those coordinates to create some, and also solve real-world problems involving coordinates. So what we're using is something called a coordinate plane. It's what we use for graphing lines and graphing rates and everything like that, and graphing bars and line graphs. What we basically see is we have an x-axis and we have a y-axis going up. Another way I think about it is I think about the x-axis, they go across, they go left to right, and then y-axis, I think about the song YMCA. So your hands go up, right? Got it? Okay, so we write our coordinates like this. I'm going to zoom in for a moment. And we write our coordinates as x and y. So x goes first. A way to remember that is you crawl before you walk, right? Or also you dribble before you shoot. You're going to the basket before you jump up. So you want to go, so your x-axis, you're going to write what your cross is and then where you go up. So that's how that major format goes for that. So what I'm going to be looking at for this is when we have something like this. We have a coordinate plane and we have three lines and it's asking you, let's say it's asking you to draw a right trapezoid, which means it has a right angle and it has two sides that are parallel. Or one side, like two pairs, or one pair of sides is parallel. So what I'm going to do is I'm going to draw a dot here. Sorry, there we go. And so what I'm going to do is I'm going to look and I'm going to draw a line. I'm going to draw my parallel, or trapezoid. Sorry for my terrible drawing ability. And then I'm going to draw to match it. Imagine that's straight. So imagine, close your eyes, it's straight. Okay, so, did it work? I hope so. But anyway, what I should be able to do is I should be able to see your trapezoid and it'll ask you, well, what is this mark? Using that, I should be able to look and say to myself, we got a 10, we go over 10, and then we go up 4. So we go over 10, so my coordinates for that spot would be 10, 4, good buddy. So we got 10 up 4. Okay, going across 10, so we start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so, and then I go up 4. 1, 2, 3, 4. And then ding, 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 we got it. Okay, so, you're going to have to ask some other things about this too. Graph a right triangle using the coordinates shown. What would be the point that you would graph that gives you a base of 8? Interesting problem. So we want to graph a right triangle so that its base is 8. So we have our coordinates here. I'm going to zoom in on that. Sorry. There we go. Beautiful. Okay, so we have this coordinate right here. That is, we go over 3 and then we go up 3. So that one is 3, 3. Okay. And then we have the coordinates, we go over 3, so 3. And then we see it went up to the 9th one. So 3, 9. So I want to make one so that its base is 8. That means that from this point here, we want to go over 8 units. Alright, so there's two ways of doing that. I could do it this way, the visual way. 3, 4, 5, 6, 7, 8. Oh, that tells me that it's a base of 8. I count over 8 units. And then I draw my right triangle. And then it looks all nice. And I'm going to make a nice little square to tell me it's right and it's correct. There's another way of doing it though. I can add, since we're making a base, follow me here. We are going to the right 8 spaces. Okay? That means I'm going to add to my x-axis 8 coordinate units. So to my x over here, I'm going to add plus 8. And that's going to give me 11, 3. Let's see if we get to the same spot. We're at 11 up 3. We got it! It's there. So I could do it this way. If I'm trying to find a base, I need to remember I'm going across 8 units, so I'm going to add that to my base, okay? If I was going to the left, I'm going to take that away from where I'm at, so I would subtract it to go there. Okay, it's knowing where I'm at. If I'm going to the right, I'm going to add x-axes. If I'm going, or my x units. If I'm going to the right, if I'm going to the left that way, I'm going to be taking away those units. If I'm going up vertically, I am increasing, so I'm going to add to my y-axis, my y label, okay, my y value. If I'm going down, I'm decreasing, and so I'm going to subtract from that. Okay, being sure that I'm visually understanding what that means. Okay, so to answer our question here, I think it was graph a right triangle. What would the point that you graph it to give you a base of 8 units? I would be 11,3. We added 8 units to 3, 3, and that got us 11,3, which was right there. And we had a base of 8 units. 1, 2, 3, 4, 5, 6, 7, 8. All right, so when identifying units and coordinates, we could do subtraction, we could add. If we're going to the right, we're adding. If we're going to the left, we're subtracting because we're decreasing in our x value. If I'm going up, I'm increasing. If I'm going down, I'm decreasing, so I subtract or add accordingly. All right, one final problem. Graph these points. What did you get? So we're going to do that. We got, sorry about that. Okay, so we got 2, 1. So 2, we're going to go over 2, up 1. So 1, 2, up 1. And I got 2, 8. So over 2, up 8. See where the y-axis is at 8? Good. 8, 8, over 8, up 8. And 8, 1. So take a look. What did we just make? Well, it looks like it is a rectangle because I see 2 pairs of parallel sides. So it would be a rectangle. And what is our area? I can look at my base and I get, well, 2 minus 8, that's going to give me a base of 6. I got that by going over from 2. 6 more units gets me to 8. Okay? Here, I'm going to draw it. Sorry, guys. I'm awful at drawing. Okay. Whoa. Okay, that was bad. I'm going up from 1 to 8. So that tells me, well, I'm going to take this away to get the height here. So 8 minus 1 is going to give me this length here, which is our height, which is 7. So 6 times 7, remember our area for a rectangle is base times height. And so I get 7 times 6, order doesn't matter. That's going to give me 42 units squared. And if it were in centimeters, it'd be centimeters squared. If it were in inches, it'd be inches squared. Perimeter, I would add all sides. So 6 plus 6 plus 7 plus 7. So 14, which is 7 plus 7, plus 12 is going to give me 26. And that's going to be units. Because we don't know. It could be inches. It could be miles. We don't know. Okay? Plural. Thank you. How can I find the base without graphing? What I could do is I could take a look at, okay, I'm going from 2, 8, and I'm going across here. So I would subtract 2 from 8. I would subtract those, and I would get a distance of 6. I could do that. Same thing with the height. I end up at 8 as our y. Okay, so I'm going to kind of erase that. I end up as 8 as my y-axis at my highest point, and my lowest point, it was at 1. So I would do 8 minus 1, and that's going to give me my height of 7. So finding my base, I would find the difference between my lowest and highest x-axes. And to find my height, I would do the difference between my y-axis labels for those. Very important to know for that. And so that's how we use graphing to graph coordinates, to solve area and perimeter. We need to be able to understand visually what's going on in this over here. So